All right. So brief introduction. My name is Carlijn de Smet, and I work at the Publications Office of the European Union on the data.europa Academy, which is our internal learning hub for open data, data policy, and data reuse across Europe. And today's webinar, we will introduce Earth observation data in Europe and also highlight the Destination Earth project as a concrete example of how the European Commission promotes the use of such data. Earth observation data plays a key role in helping us understand our planet, and it supports a wide range of applications, from monitoring environmental and climate-related change to improving disaster preparedness, as well as informing policy decisions with robust data-based evidence. A central focus of today's webinar will be Destination Earth, which is a flagship EU initiative aiming to create a highly accurate digital twin of planet Earth. By modeling natural phenomena and human activity, Destination Earth seeks to support evidence-based policy-making, as well as scientific research and informed decision-making all across Europe. Before we begin, I would just like to provide a few practical notes for this webinar. This session is going to be recorded. The recording and the presentation slides will be made available on the data.europa Academy page and also shared with you after the event via mail. Please note this takes about a week, but we will get back to you as soon as possible. At the end of the webinar, we will also invite you to complete a short feedback survey, which will appear on screen, as well as a QR code. We would really appreciate it if you would fill it in to help us improve further sessions at the data.europa Academy. And during the session, please post any questions you may have in the chat. We will collect them all and address them during the Q&A session at the end with all of the speakers. So please share all your curious insights in the session today. Now I would like to introduce today's speakers. First, we have Dr. Thore Fechner. Thore leads the Open Data and Copernicus team at Conterra, where he's been working since 2013. His work focuses on open data and the EU's Copernicus Earth Observation Program, combining consulting and project management activities. At the federal level in Germany, he advises public authorities on data management and reporting processes related to initiatives such as Inspire, open data, and environmental reporting. Thore holds a doctorate in geoinformatics from the University of Münster. Today, he will open the session with an introduction to Earth observation data, explaining what it is, why it matters, and how it supports science, policy, and society. Next, I would like to welcome Daniel Draghicescu. Daniel is a policy officer at the European Commission, specifically at DG CNECT, where he provides strategic oversight and guidance on the implementation of Destination Earth. He brings over 17 years of experience across systems engineering, artificial intelligence, project management, and large-scale program management, spanning both the private and public sectors. Prior to joining the Commission, Daniel worked at Microsoft as a senior product manager for sovereign cloud solutions and spent more than a decade at the Airbus Defence and Space, where he led research and operational projects in AI and defense management. In today's session, Daniel will be presenting the policy and strategic context of Destination Earth, including its objectives, use cases, and its role within the wider EU data ecosystem. But last but not least, we also have Michael Schick with us today. Michael Schick is a principal engineer at EUMETSAT, where he works in the digital solution and SAF division. He oversees roadmaps, concepts, and strategies for divisional services, with a strong focus on creating symmetries across activities and ensuring seamless delivery service. Over more than 20 years at EUMETSAT, Michael has contributed to a wide range of user-centric services, including the Earth Observation Portal, the EUMETSAT Data Store, and the EUMETSAT Data Lake. He currently leads EUMETSAT's contribution to Destination Earth, particularly in relation to the Data Lake. Michael will conclude the presentation with a technical and operational overview of Destination Earth, explaining how the platform, Data Lake, and digital twins interact. So just quickly before we start, I want to guide you again through the agenda. I already touched upon it briefly just now, but we just opened the session. I will hand it off soon to Thore to introduce Earth observation. Then Daniel will talk about the policy and strategic context of Destination Earth. And then Michael will cover the platform, data lake, and digital twins. And then we'll all gather again at 11:10 for a Q&A session and the closing remark. And with that, I would like to begin. So it's my pleasure to give the floor to Thore, who will introduce us to observation data and its relevance for science, policy, and society. Thore, the floor is yours.
Thank you very much. Good morning to everybody in the webinar. I'm very happy to be able to introduce you to this concept with a very brief introduction, outlining a couple of examples and brief theoretical background. So what is Earth observation data? Earth observation means collecting information about the Earth, so the entire ecosystem, the globe, without direct contact, mainly using satellites, aircraft, and ground sensors. So it's encompassing everything which is there. Earth observation data helps us, in essence, to understand what is happening on the planet now and over time. So usually we create large time series spanning decades, looking back, and then using this data to extrapolate activities, things, to science, which will happen in the future. And we will see this in the presentations of the other colleagues later on, especially in the context of Destination Earth. What is Earth observation data? As I said, it's data about the globe. It's data about land, oceans, atmosphere, human activities, which is collected repeatedly and consistently. It all started with single images way back when we had Landsat images in the 70s or so. And now we have programs like Copernicus, which collect data openly, publicly, for free, monitoring the globe in its entirety using different sensors. Examples are satellite images you can look at and are used to looking at, perhaps, if you look at maps. But also there's other kinds of sensors which monitor temperature, air quality, land use and vegetation, sea level, and ice cover data. And this is all collected using different sensors, for example, from the Copernicus program or very other specialized satellites with tools that measure different things on the Earth, in the globe. Why is Earth observation data special? It usually covers the entire globe. So we can make informed decisions or analyze the data, not in isolation, but rather in the entire context, which is really helpful if you want to understand how we live on Earth, right? And as I already said, we have the long time series, and we can make comparisons between countries or within countries because we have this larger, broad context. How is it collected? The main sources are threefold. Satellites, as I mentioned already, in the European Union, the European Commission, Copernicus, the Sentinel satellites are the most prominent at the moment, but it has a long history using previous missions. Then we have area platforms, drones or aircraft, which collect data, or ground stations, which are, for example, weather stations or other sensors which are there. And usually we make the distinction between the space-based component and the in situ component, which is everything which is not space-based, so a satellite. The satellites, as already was hinted at, just don't take photos. They measure radiation, temperature, moisture, movement, and more, meaning we get a complete picture of the Earth. So it's not just a picture you look at, but rather the entire system, what is happening in the atmosphere, on the ground, in the ocean, and everything basically in between. Earth observation data can be accessed via various platforms and means. One of them is the European Data Portal, where you can, for example, find metadata sets and links to the EUMETSAT product navigator, but there's various other sources from ESA or Destination Earth, where you can also collect the data which is actually being processed there, prepared, and then distributed. And in order to disseminate it to a broad audience, there's various interconnected systems and portals offering up access to this information, which is highly valuable. So from raw data to information, right? How is it happening? The data is collected by sensors, for example, the space-based components, the satellites, measuring temperature in the atmosphere. It's then sent to the ground segment, being processed and corrected. And then it's combined usually with other data in order to make it easier to use this in your workflows for your curiosity for science or for policy that you want to ground in actual data. And it's then usually to make it even more accessible, turned into maps, indicators, and dashboards, so that you don't have to create the entire processing pipeline on your own, to make it more accessible, to make it easier to use. What is Earth observation data used for? As already was hinted at, it's...
All right, Thor should be back. Hi, Thor. All right. Thank you all for your patience. Let's get back to Thor's presentation.
Thank you. I'm so sorry. Apparently the connectivity is still an issue when we're talking about space-based sensors. The actual internet connectivity could be improved upon. I'm sorry again. So I was talking about the use cases and the fact where Earth observation data is used for. So for example, the environment and monitoring climate, or making predictions about climate change, or assessing how climate change will affect us. For example, the deforestation and biodiversity, or the air and weather quality. But also Earth observation data can be used for urban and societal questions to gather insights, for example, urban sprawl, urban growth, or land use. Also for traffic monitoring and mobility questions, or for disaster management, risk management, and emergency response. Usually with large disasters, for example, floodings, there's the need for gathering large-scale information to quickly assess on how and where to deploy relief forces, for example. And the European Commission has several systems in place, like LOFAS and EFAS, which are flood monitoring systems, especially designed for such purposes. Also provides evidence for policies, so example, to make comparable results and do evidence-based decisions across regions, and especially across time, because we collect large time series data.
All right. I think we are going to move to Daniel quickly, just because of time. And I also noticed that Thor is still having difficulties. Daniel, are you ready to step in?
Yes, I am here.
Great. Thank you so much.
Maybe we can play the video first. Perfect. So I really hope you liked the video. It's a nice overview, and it's exactly the topic that I'm going to discuss today. And really happy to see so much interest and so many participants attending here. Hi everyone, my name is Daniel Draghicescu. I'm a policy officer at the European Commission in DG CNECT. I'm also the technical lead on Destination Earth, and today for the next 20 to 25 minutes, I'm going to give you a brief overview on the policy aspect of Destination Earth. Really hope this is going to be an interesting presentation. So let's start with the basics. What is Destination Earth and why are we talking about Destination Earth? Destination Earth is the flagship initiative of the European Commission, which aims to create a highly accurate digital twin of the Earth. The main purpose of the digital twin is to monitor, to simulate, and to predict the natural phenomena and the impact of human activity on Earth. This is part of the ambition of the EU to accelerate the Green Deal and the digital transformation. And how this is achieved is by creating what we try to call what-if scenarios. This is going to be a term you might hear a bit today. Create these what-if scenarios with the purpose of integrated impact sectors into applications for a more sustainable development. All this should be seen as transversal to support the decision-making at various levels, EU level, but of course also national, regional, going up until the local level. Destination Earth is led by DG CNECT in coordination with the member states and the associated countries, and it's implemented by our free and trusted entities, ECMWF, ESA, and EUMETSAT. This is a large program. It's part of the Digital Europe program. It's estimated around 500 million euros in total for a period of around 8 years. It also includes important research and innovation activities under the Horizon Europe program, and it brings the entire European ecosystem together. From example, I have some numbers on screen: 27 countries, 60 private institutions, 160 organizations, 24 SMEs. So this is just to show the scale of Destination Earth and how it actually aims to bring together not only the end goal, but also all the industry within Europe to contribute to this initiative. From the bird's eye perspective, if we were to zoom out at Destination Earth, we have the free implementing entities which have their own distinct responsibilities. So starting from the left, we have ECMWF, which has the responsibility of the digital twins. So they are the ones developing the weather extreme twin and the climate digital twin, utilizing also the high performance computing power of EuroHPC. This basically means that these being physics models, they require high performance computing power, so they require actual HPC computing, which is provided by our partnership with EuroHPC. Then we have EUMETSAT, which is responsible for the data lake. All that means storing and processing the digital twin data. And we have ESA, which is responsible for the core platform, which is the main entry point from the user perspective to Destination Earth. From an implementation roadmap perspective, the kickoff started in 2022, where the European Commission signed the initiative based on contribution agreements. Contribution agreements means that the development is fully entrusted to the free implementing entities, ESA, ECMWF, and the EUMETSAT. Development started around 2023 with the first launch in June 2024. So after just 1 year of development, we had the first version live. Now we are part of phase 2 execution, which is coming near to an end up until this year in mid-2026, where we are enhancing the system, stabilizing the system, further integration with the digital twins. And the plan is to transition towards the long-term operations, which is post-2028, or what we called end of phase 3, where the digital twins will be fully completed, the system will be fully operationalized, and people will actually start using it and get an actual benefit out of it. At this moment, we have 3 main components. The core service platform, the one which I said was developed by ESA. Here we have the end user interaction. This is where the users first go to the page and log in and see all the services. Now we have around 33 services. We also provide data access services. We provide data processing services, for example, methods for users to exploit and manipulate the data, visualization services, and we also enable the collaboration between the wider ecosystem across Europe to achieve a higher impact. The data lake, which is under EUMETSAT responsibility, these are geographically distributed near data processing, so that's a fancy term of saying cloud deployments. The purpose is to access the data portfolio, including some federated data sets, and also to store the digital twin data. When we talk about digital twin data storage, we talk about petabytes. So this infrastructure is specifically deployed in order to achieve this high storage capacity. And of course, because it's like a cloud-like infrastructure, we also have GPUs. So we are also able to provide AI capabilities for training and for inference of models. And the digital twins from ECMWF, there are two of them. We have the Extremes DT and the Climate DT. The Extremes DT focuses on extreme weather events. They produce regularly at 4.4 kilometers with the specific feature, which is the on-demand zoom, which goes to 500 to 750 meters. And we have the Climate DT, which aims for a multi-decadal projection with an extremely high resolution, aiming towards 2050 as a timeline. And the first prototype, which is now implemented, actually has a really high resolution of 5 kilometers across the entire Earth system. People usually don't necessarily know exactly about digital twins because, unlike AI, which is on everyone's lips today, this is a concept which is not that visible. So in principle, to explain what digital twins actually mean, we have two examples. This doesn't mean necessarily that these are the examples implemented within Destination Earth, but they are really good examples to frame the context of digital twins. So in principle, digital twins are used to simulate scenarios and tailor information. This is what we call the what-if scenarios. So for example, if you are an energy provider and you have ownership of specific windmills, which are wind-powered, you might have a question, which is your what-if scenario: how will an approaching storm affect the renewable energy production on my wind park? Or, for example, let's say that you are a city planner and you work in the urban domain and you want to explore future scenarios. For example, how would a specific heat wave look in a +2 or a +4 degree warmer world, and how should I adapt my city in order to achieve this? This is what we call the what-if scenarios. Again, these are only some examples here to highlight, but Destination Earth in principle will be a collection of what-if scenarios to enable different impact sectors. Discussing about the Extremes DT, which focuses on weather events, how this works. Basically, there's a daily simulation which runs across the entire Earth. So we have like the global scale simulation, which maps all extreme weather events during 4 days at the 4.4 kilometers. So this is we can call it the Earth-wide prediction of extreme events. When a specific event is being identified in a specific region, we have what it's called the on-demand simulation. So this means that the system is capable to zoom into a specific region at a much wider resolution, so between 750 to 500 meters, and we'll do the simulation for 2 days ahead to see how that extreme event will actually impact at a lower scale the specific region. And with this information, we can start mapping the impact sectors and moving towards the what-if scenario, so that we actually extract the user-relevant information and see how the societal impact will actually take place after the extreme event. From the climate digital twin perspective, which is the other digital twin, this picture is quite interesting because in the middle you see like the actuals of 2019, where we have the heat wave in France, with the zoom on Paris, where you see the little red dot. We have something quite interesting, which is called storyline simulations. So here we try to answer the question: what would the heat wave look like in the past and in the future in a climate variation. So for example, you could see that in 1950, where maybe climate change didn't have that much of an impact, the effect weren't that significant, but in a wider climate, so only a +2-degree variation in 2050, just look at the variation between 2090 and the simulation of 2050. This is like a really good representation, even a visual representation for people to understand what would be the impact if something which happened now would actually happen in the future in various climate scenarios. And of course, we will have the capability to variate these scenarios. So the +2-degree, it's let's say baseline scenario which is being used now, but in the long run, Destination Earth will be able to variate these scenarios and to provide multiple what-if scenarios. This is a slide I like a lot. It's not a video, don't worry, so it shouldn't supposed to move. It's a screenshot from a video which shows a comparison between the current predictions simulations of Destination Earth, the climate simulation, and the what is considered the baseline. Above, you have the 100 kilometer simulation. So this has been considered like the state of the art for a really long time. Below, just look at the level of details that the digital twin is able to produce based on the data of climate simulation. So you can see even visually the extreme detail, which is now able to be replicated and to be simulated via the climate digital twin. Remember, this is worldwide, so the climate twin is able to do this at a world level. So this is an image which clearly highlights a clear benefit from the resolution perspective of the digital twins and of the great improvement that we are trying to do with this European initiative. Of course, there is AI in Destination Earth. I assume this would be a question on everybody's lips. Like I mentioned a bit earlier, when we talk about the digital twins, these are physics-based models, meaning they rely on the physical properties of the Earth. We are also aiming to shift a bit towards AI. So we start from an atmospheric AI model, which exists, and the plan is to develop multiple AI models, which will be the land, ocean, sea, ice, wave, and hydrology model, which together will be able to complement the physical model with AI-based capacity, and also to target the impact sectors. Huge benefit of this approach would actually be the simulation execution time, because in principle, running physics-based simulations like the weather and extremes DT, they require the high performance computing that I mentioned earlier. So there's a lot of data processing required in order to achieve the simulations, while the AI models will be optimized and they will be able to execute much more faster with comparable predictions. This is an ongoing activity. It's planned in the same timeline with the execution of Destination Earth. So it means that up until end of 2028, the plan is to have all these elements in place. From a data perspective, we have the two major components, the climate change adaptation digital twin and the weather-induced extremes digital twin, which together represent the petabytes of data of simulations in specific what-if scenarios, which are stored on the data bridge. But we don't have only this. We actually have more than 200 federated data sets. For example, Copernicus Earth observation data, which was mentioned in the previous presentation. Through Destination Earth, you can actually access all these entire federated data sets. So you have the capability not to work only with the climate and the weather-induced extremes, but also to consume data from the federated data sets and to build your solutions together. And because Destination Earth is not only a concept on paper, it actually exists. So we have the platform, we have the main entry point for the end users. You can actually go to platform.destiny.eu. You can register, you can check out the service. We are more than happy to have you on board and also to listen to your feedback on how you interact with the platform and with the services on the platform. And of course, to see how together we can bring benefit across the entire European Union. And usually when I do this presentation, that was the slide which was the ending slide. But because this is a special event, I have 3 more slides. Because I talked a lot about Destination Earth, and I zoomed into Destination Earth and its components and how Destination Earth is being built and the life cycle of Destination Earth. But this time I want to zoom out a bit, because Destination Earth, even if it's already a huge initiative, it's actually part of something bigger, and this relates to data. So I thought it's going to be interesting for this session. That's why I'm going to throw around a bunch of breadcrumbs. Usually, when we talk about the commission space, you know that information is public, so I will not go into a lot of details about this information, but feel free to take these breadcrumbs and then search around the internet with your favorite search provider and look around at the public information available on this topics. The first topic is the Common European Data Space. So the Common European Data Spaces is an initiative of the European Commission to build a secure and trustworthy environment where data is shared. So this provides the technical infrastructure which allows the transfer or access of the data, and a governance framework which defines the data sharing and the usage policy. So here we talk about data spaces where in principle, we have a data holder, which is the data provider, and we have a data consumer, which is interested in consuming that data. There are a lot of common European data spaces at this moment. Destination Earth is part of the Green Deal data space. But there are also other data spaces on finance, mobility, energy, public administration, and so on. All these data spaces will be integrated in the future by something which is called the simple middleware, which is, as the name states, a middleware which will enable the technical infrastructure and the governance in order to access data between data spaces. So the advantage of being in this common European data space is that even though you see from the perspective of Destination Earth, which is inside the Green Deal, you will be able to use not only data from within the Green Deal data space, but also data from other data spaces. Then we have the AI factories. When I mentioned the Euro HPC in the second slide, I talked about the high-performance computing, which is already a state-of-the-art provided by the Commission with the support of the Commission at European level. Now we talk about AI factories and the AI gigafactories. The AI factories plan to leverage the supercomputing capacity of the Euro HPC joint undertaking to develop trustworthy cutting-edge AI models. So more or less, the AI factories will be the future ecosystem that foster innovation, collaboration, and development in the field of artificial intelligence. So they will provide the actual infrastructure and the tools which are needed for the Europeans to train the next generation of AI models and to consume the next generation of AI models. This will foster the collaboration across Europe, linking all the supercomputer centers, universities, SMEs, and industry together. So we see the AI factories as a hub for driving advancement in AI applications in various domains such as health, manufacturing, finance, space, and of course, climate. So how this all fits together in the big picture, we have an action plan which is called the AI Continent Action Plan, which has 5 distinct pillars. We have data, computing, algorithms, skills, and regulatory simplification. Out of this AI Continent Action Plan, Destination Earth already touches on 3 aspects, meaning the data, where it's the relation with the data spaces and the Green Deal data space, where Destination Earth will be a consumer and a provider of data. We have the AI factories, which will provide the computing infrastructure in order to train the future models, also based on climate and weather data. And Destination Earth is already part of the Apply AI strategy, which sets the ground for the future AI developments across Europe. And Destination Earth is there in the dedicated section on climate and events and weather events. So I hope you found this really interesting. I hope you will take a lot of information back with you home. And I really hope this actually caught your attention and you will look into Destination Earth, and that together we will actually contribute to the future of the European Union on the perspective of data related to weather and climate. Thank you so much, everyone. And now I pass the floor to Michael.
Welcome, everybody. My name is Michael Schick. I'm working for EUMETSAT, and I prepared the presentation where we go under the hood about the 3 different components: the core platform, data lake, and digital twins. And the slides that I'm presenting, I had a contribution from my colleagues at ESA and ECMWF, and I will show you now the following slides. You saw this slide before, presented by Daniel. Here it is enriched with some additional information. You can see again, so I remind you, so ECMWF has done the digital twins, EUMETSAT the data lake, and ESA the core platform. And at ECMWF side, Daniel mentioned there's a hybrid physical model and AI and regarding weather and climate timescales. We have multiple models there, and it's powered, and the digital twin engine is used by ECMWF, and it's deployed and run, or the model outputs are generated across the Euro HPC network. So we have many HPC computers used around Europe. You see the names there of the HPC computers like Lumi, Leonardo, Mare Nostrum, etc. And then we have the data lake, which is also geophysically distributed, and the core platform from ESA, where the user are actually landing or starting their journey. Here you see as well listed the number of countries and organizations which helped contributing to establish Destination Earth. So now I'm going to dive into the digital twins from ECMWF. So what Daniel has explained before, Destiny offers a unique capability to perform bespoke simulations on Europe's best supercomputers and to provide answers to so-called what-if questions. So we have 2 digital twins presently today available. The weather-induced extreme digital twins providing forecast for a few days ahead. And we have the climate change adaptation digital twin, which goes multi-decadal timescales for different climate scenarios. So on this slide, you see a representation of the key characteristics of the digital twin technology that ECMWF has applied when implementing the digital twins. You see a reference on the bottom below pointing to a research paper that ECMWF has written, and I encourage you to follow this link and read up in more depth if you're interested about the digital twin technology and how it was implemented on Destination Earth. There are a couple of important features to be highlighted. You see them at the bottom. So we need to have enhanced flexibility, bespoke simulations and their output. We need to have frequent updates of the model outputs, including on-demand prediction with increased spatial and temporal resolution. So Daniel has shown that before on some of the slides. And we need the sort of integration of the workflows with sectoral models. Also, innovative AI usage is in that context applied. And also, last and least, state-of-the-art information provision provided. On this slide, you see from Destination Earth the different climate projections. They are made available via 3 different leading European models: ICON, FESOM, and IFS NEMO. So the climate projections are available and the outputs are based on these models. So on that slide, you see at the bottom the characteristics. Daniel mentioned that before. So we have state-of-the-art information versus climate DT sort of capabilities. You see, for example, the state of the art is about 3 to 6 hourly data versus destination Earth with 1 hourly data. The resolution is quite high. Daniel showed it on the picture before. So it's 5 kilometer global resolution versus high resolution. For example, the CMAP is at in high resolution at 25 to 50 kilometers and the standard resolution at 100 kilometers. This slide shows the extreme DT and also the end-to-end framework for producing bespoke extreme DT information and exploiting the what-if information. And here, so every day, the output is produced, simulating extreme events 4 days ahead in time at a resolution of 4.4 kilometers. There's also the possibility to do regional, or we can trigger regional execution on demand to zoom in into a flexible domain to inspect extreme weather conditions in Europe 2 days ahead at sub-kilometer scale. And Daniel mentioned as well that impact sector models are integrated directly into the global or into the regional component. So unfortunately, you cannot see the video on these slides. There were some video animations, but it's on the PDF. You don't see it. So it demonstrated here, it zoomed in, so from the global scale into the regional scale, and shows here an example of what's actually been possible. So we are presently working in the phase 3 on some other examples, and you see here things which you can support at decameter scale. So heat-related excess mortality for Prague, or number of tropical nights for Lisbon. On the left side, you see Era 5 reanalysis data and climate ET projection and scenarios. So on that slide, you see that the digital twin engine is already an AI-enabled software infrastructure. And so the details you can read up in the referenced scientific paper, which I had shown at slide 5. So as part of the digital twin engine, you have various services which are part of the stack. So there's a data access service called Polytop. And with Polytop, you can actually navigate very efficiently an n-dimensional cube and look at specific parameters of the simulations available. And you can extract it and visualize it using a semantic data access with the tool EarthKit. And you can then easily visualize and plot that. And all of that is conformance to industry standards. ECMWF has also used and is presently working on extending the Anemoy framework. And Anemoy framework is an open source framework which was developed together with their member states for the usage of AI also in destination Earth. And you see here a couple of components that Anemoy consists, and it's supposed to produce AI-ready data collections of the digital twin outputs, so for using in the AI factories that Daniel mentioned before. So here are as well some other outlook on things that will be done by ECMWF in the coming period and over the next 2 years. So AI will be used for completing the Earth system model. We will have something called Forecast in a Box, and also a chatbot, which is a sort of digital twin assistant, where in natural language you can ask questions, and then Destination Earth and the system will reply you with the information that you were looking for or you desired to look at. So now I'm moving on to the next component, so the core platform from ESA. So the core platform from ESA is a flexible ecosystem of services allowing you to discover digital twin outputs, but also the other federated data sets that we have. And it's actually the landing page, and it can host thousands of users with a variety of background. So you find services there for the normal citizen, you find services there for a kind of developer, but also things that are meant for principal investigators. And the core platform itself is operated on European sovereign cloud solution. So it's on OVH cloud, and it supports operational and scalable usage of all the services. We see here an example of some of the services that you can access on the core platform. On the left side is a bit small. Here are some examples of different services that you can exploit. Daniel mentioned that there are about above 30 services presently available. They can be grouped into data access, data processing, visualization. What was not mentioned before is that Destination Earth, or the access to the platform, is all open and free. So you're all welcome to access the service and exploit a little bit there. After the registration, you have to ask for an enhanced access to access the digital twin outputs. And then you could play with visualization services, look at the different stories that are available there through DIA, and you can use different means for accessing with the data and workflow. So what I mentioned before from ECMWF, there's Polytorp, but we have also Eden, Sesame, or the harmonized data access from the data lake. There are also further services, and they are sort of like the level above, and they allow you to do certain things, for example, based on thematics. So, for example, regarding thematics of urban questions, there may be things that regarding electricity or tourism. So they are ready to use applications which are hosted there and which can help you answering certain questions that you're looking for. If you go to the platform, you can find under the links that are visible here on that slide, you can find information of how we will evolve over time. So there's a public roadmap. You find details of what's happening in the near future, but also you find certain platform news about different services when they're upgraded or what has actually been changed. On that slide, it's mentioning that it's an enlarging and diversing ecosystem, Destination Earth. And here is actually listed how ESA overall managed the core platform. So sort of what is being applied so that it's always strive for the best practices. There are open calls made, and there's a constant onboarding for new services into the core platform. So moving now to the Destination Earth data lake to give a dive in. So that's from EUMETSAT. And I have here a slide showing in a nutshell what the data lake actually provides. It's actually built on 3 essential pillars: a distributed infrastructure. We have the discovery data access, big data processing services and tools, which you can exploit. And in the nutshell, on the diagram on the top one, you see on the right side the digital twins from ECMWF, left side the core platform, around the different data spaces or the thematic areas, and then in the center we show the different pillars from the data lake itself. And on the bottom you see the different HPCs and the geographic distribution. But I have it as well on the next slide. So at the beginning, at the introduction, it was mentioned that we are using Euro HPC across Europe, like Lumi, which is in Finland, and that one is used since June 23. Leonardo HPC, it's as well usable from January 24, and in Barcelona, Mare Nostrum. And we have as well major data holdings because the data lake is geographically distributed. We have major data holdings at the EUMETSAT data center, but as well at Cloudflare in Warsaw, where we have access to a lot of Copernicus data And at the bottom, you see in this chart a footprint of the sheer capacity that we have in terms of storage. So 120 petabytes is presently available, the number of GPUs and CPUs, and Daniel mentioned as well before the 200 plus data sets. That leads me then to the next slide regarding the Destination Earth data portfolio. So obviously the core and the most important are the digital twin data from ECMWF. So you see it as well in this chart here on top, on the top left side. So there are again the key characteristics described of digital twin data, but we have as well federated data sets. And important to notice is that the federated data sets, they will evolve over time. So we upgrade and enhance the portfolio depending on the needs. So through user exchanges and communication with others, and depending on the needs, the data portfolio is not fixed, but it will evolve. And there's also something, a notion of user-generated data. And what it means is actually if we have on board certain thematic digital twin components and they produce output data for complementing the Earth system model, then that data can also be offered throughout the Destiny data portfolio and or stored in the data lake itself. Some characteristics here on the harmonized data access in combination with the data portfolio. The harmonized data access can actually be used with one credential. So once you registered on the core platform, you can use then those credentials to access the entire data portfolio. So using one API, it's stack-based. We have 200 data sets and in the moment 15 different providers, but it's further growing. What we offer on the lake itself are some key services. They are called edge services on our side. You see that at the bottom. We have given them specific names like Stack, which is a Jupyter notebook, a Jupyter Hub. We have ESLAT, it's infrastructure as a storage, and workflow execution is called Hook. The idea is here that people which actually, when you come to the core platform, if you have a service that can be of benefit to the Destination Earth community, then that service can be deployed in the core platform under operational grade, and it's maintained for the bigger audience. But if people come and want to evaluate themselves what-if questions or do analysis, then they can request edge services on the data lake and can do the undertaking there close to the data. I have here a short outlook, what we will be offering soon to users. So we will have a data lake assistant, which is AI-based, which helps users then around the edge services to discover and navigate the documentation or get some more details about the collections, the different use cases that we have available, or there are a lot of Jupyter notebooks available. But you find as well when you register on the core platforms, Jupyter notebooks in Insula. And so if you have interest after this seminar and that session, then you go to the platform, register. You may dive into the Insula service and use Jupyter notebooks to exploit and plot some data. What we will also further do in complementing what ECMWF is also doing for the digital twins. ECMWF is producing AI-ready data for the digital twins, but on the data lake, we are going to do that for satellite data. So in the same sense, so that this is available and can actually be used to be used as input as well for the AI gigafactories and the AI factories in the sort of sense, because all the data is there available. And then we provide as well in the data lake as well, next to the edge services, machine learning operations or a platform that can be used to do also AI advancements and AI model developments. However, very small models, because the data lake itself is based on OpenStack and not in HPC. So maybe simple models can be done in the data lake itself. And then for the harmonized data access, we're offering the data in the native format as it is. But So it could be useful for users in the future as well to have analysis ready data available. So we are working on a cube service to put some of the satellite data into cubes so that they are analysis ready and can be easier navigated. So similar to what ECM-WMF does with the Polytop service. Thank you. That's it from my side regarding Under the Hood.
Thank you very much, Michael. And for the rest of all of the speakers, it was a very, very interesting presentation. I think you did a really great job introducing and really taking us through all of the facets of Destination Earth and Earth observation data. So I really want to thank you all for that. We're now going to move on to the Q&A, which we've prepared all of the questions that you've sent us. So yeah, I'm going to start with Thore, because we got to hear only, unfortunately, very little of you. So we'd like to hear some more insights from you, obviously. So I'd like to start with the question, if you could elaborate a little bit more on where it is possible to find the Earth observation open data repositories. Yeah, talk us through that a little bit more.
I for sure can answer that, but I think that my colleagues have also very strong opinions about that. So, for example, EUMETSAT, the user portal, is a great place. The ESA data space is a great place to access Copernicus data. The various open data portals, you'll find that in the EU as well. So there's multiple pathways for different audiences.
Anything else to add from Daniel and Michael's side, perhaps?
Yeah, I can add what Thore said is correct. So we have many great places where you can access the data. Yeah, so it's the Copernicus data space ecosystem. It's for the Copernicus world. We have as well WIKEO. They're available. So there are two solutions where you can find the data. You find data at ESA. There are various access points to get into access to the ESA data. But there are as well many other portals from other organizations like from CNES and from ASI, etc. So there's quite a lot. And I think the European data portal is quite good as an entry point to actually find some of these entries, and then you can actually navigate on from there on to explore further and go in depth. And but there's not I think it's the best place maybe to start and find some things. Destination Earth is not listed on the European data portal yet, but maybe we add it in the future there. Yeah, so to as well be able to go across.
Great. Sounds very good. Sounds like there's a lot out there for all users to engage with. Then I would like to move to a question for Daniel. One of the users asked, do you think it's possible to achieve a single official digital terrain model for Europe in the future? The participant mentioned that this would be essential for ensuring data quality and consistency, as well as interoperability and the development of more efficient systems and services.
That's a really interesting question. Short answer is, I think it should be analyzed, because it's difficult to state directly if a single source would be like sufficient. My intuition would most likely aim towards a combination of elements, but on the other hand, I'm not a subject matter expert, so I can easily be contradicted. So I think it's a difficult question, honestly. I don't have the answer. I would say it's for the experts to try to answer this one. For now, our approach is to look at combining elements, but this approach is also feasible in what we are trying to achieve, the digital twin of the Earth from the perspective of weather and climate. The more we add, there might be the question, would it make sense to try to actually integrate into a single element? But I will leave this question for posterity, so for the future, because I honestly can't tell now if it would be like the best approach or not.
No, but thank you for your insights. I think everyone has personal preferences here. I'm sure about it. Then I have a question for Michael. Are there maps or information about the coastal erosion or flooding of coastal regions, either in relation to the climate scenarios and projections presented or independently of them?
This is a tricky question. I think it's not directly available. I know that, for example, I've seen on the, I was in a workshop, on a science workshop from ESA, and some of the information is available maybe in the digital twin of the ocean or in that respect, or I've seen some stuff appearing in some digital twin models for coastal lines, but I would have to dive into and find out a bit more in the details.
Okay, thank you for your answering. Then I have another question for Thor. How deep is the geographical granularity of the collected data that you presented?
Depends on the sensor you're actually using. So if you use a satellite, which is from the Copernicus program, a Sentinel satellite, depends on the actual sensor of the satellite and the thing you want to measure. So there's different resolutions for different sensing tasks. If you have aerial views, then you can go down to centimeter accuracy. If you use drones, even sub-centimeter accuracy. Really depends on what you want to investigate, I would say. For the space-based stuff, it's around, for the open data, as far as I'm aware, for the optical things, lots of qualifications, 10 to 20 meters in the Copernicus context, kilometers for other sensing environments or sensors. So depends.
Okay. I think there's a lot of ambiguity in the answers today. Then I have another question for Daniel. Is the data quality consistent worldwide, or is it better in regions like Europe? The participant understood that satellites provide global coverage, but it seems you also rely on data from, for example, windmills or planes flying, and those are not obviously distributed equally across the world.
I wouldn't say we rely specifically on data from windmills and other elements. Those were, I mean, the windmill was provided as an example for a what-if scenario. So considering that your scenario targets renewable energy production, for example, then you might have specific simulations based on this. But it's not necessarily that we use that data. So the data which is being used is at global scale and comes from the Earth observation data plus the meteorological data, which contributes to the weather extremes and to the climate projection. When we go down to the lower level, and as a small parenthesis, what I'm saying now, it's also part of the, it's not necessarily existing at this moment, but it's part of the plan, because remember the deadline is after 2028 for everything to be ready. Our plan when we go to local scale is to indeed integrate with other data, but those data sets will come from the local level, meaning they will have another tailored quality and another reliability measurement compared to the global one. So now when we talk global, we mostly talk Earth observations, we talk, I don't know, ERA 5 reinterpretation of data, weather data, climate data. This is the global part that we are discussing.
Great, thank you for clarifying. Then I have another question for Michael. Why is there an enhanced access barrier to access the digital twin? What kind of requirements do you have to fulfill to get to enhanced access?
Well, I think I would pass the question to Daniel to answer it from the Commission. So I think I can say from my point of view, so we had on Destination Earth initially a gradual opening, and there were some good reasons for that, and maybe Daniel can explain it a bit. And so we go now from being a bit more restricted, we went now wider and wider, but I let Daniel give the official answer.
The system is still under development, and because it's under development, we also wanted to make sure we don't create a lot of noise up until we have like the proper confidence that everything it's ready. So that's why we opted for a gradual opening. Initially, we opened it for the actual development developers which were developing the services. Now, because we have a really good, let's say, stable base of services also oriented towards the end users, we extended this access. So now the access is open to everyone at EU level, basically EU level or DEP associated countries level. Meaning regardless if you're academia, research, if you're from a public institution, if you're a private entity like an SME startup corporation from within the European space, the European Union space, plus the DEP countries, associated countries, then access will be granted. So it's purely due to the reasons of the system being under development and making sure that we don't create some noise related to some data or services which are still evolving.
Clear. Thank you. Then I have another question for Michael, since Daniel took this question. Are you storing any vector data in the data lake? And are these data used to support modeling for any purpose?
The data sets, yes, in theory, there is some vector data available as well in the data lake. On the data sets, you have to look particular. Also, out of my head, I could name one or two, but it's also available there, and it could be combined. So the idea is as well that in some of the services, you can fuse the data together and can use it for modeling, but then it depends on the need. Also, what is to be said is that what you can access presently in the data portfolio, it's not limited that you only can use that data. So you can, from the core platform, but also from the data lake, access the internet. And then theoretically, if you have other data that you want to use, you can actually access it via APIs or over the internet, and can also take it into account into your environment for further processing. And generally, the data portfolio, when we enhance with new data sets, we look, is it of use for a bigger audience? So if it's for a single project or for a single undertaking, we don't necessarily add it to the portfolio itself. But if it's of wider use, we would enhance the portfolio. And then if it's only for a single purpose or for a single thematic or very specific in situ data, then the projects can actually access it via the internet.
Nice. Thank you for those insights. Then I have one more question for Daniel. How can small businesses and startups participate? Is it possible for companies to get access to run their AI models on supercomputers or not?
I would assume the question is okay. There's a small nuance to the question which goes a bit outside of destinationer, because I'm not really sure about access on the supercomputers.
I can help you with this, Daniel. So it's possible. So in principle, SMEs and startups, they can access, for example, to exploit certain things on Destination Earth. They can access the edge services, but it's OpenStack. If it goes to the HPC world, they can actually request projects there. And in the context, for example, of the AI factories, SMEs and startups, they can apply for a grant to be able to do these activities on the Euro HPCs. And they have calls open, and they could apply, and they could get granted the access, and then they could do the things on the HPCs. So it's not via Destination Earth, but it would go via AI factory calls. Mm-hmm. And I think if you search a bit on the internet, you can find it, how you can subscribe. Other than that, they could also apply for normal projects, and then sometimes you have to pay for it, but sometimes it's sponsored.
And if I can complement a bit, of course, within the limits of Destination Earth, you can also have access to computing power, both on the platform and on the edge services, or the cloud lighting infrastructure that me and Michael were mentioning. Of course, there the processing power, or the capacity, it's a bit limited. It is, of course, free because it is under that money, but it also has some limitations. So you might, that's why it depends a bit also on your needs to.
Yes.
Yeah, so the number of GPUs that are available that we can provide is limited. So it's not that you can use like tens of GPUs. So it's more like you have maybe a part of a GPU for certain things. And if that is sufficient, if it's a very small model or a medium-sized model, then it might be good enough to exploit something initially, and then maybe SMEs and startup could also go big, yeah, and then they could go across to the HPCs.
And my last comment on this, because it seems it was a really interesting question, which actually opened a lot of areas of discussion. If the question was related to actually contributing to Destination Earth ecosystem, because that could also have been a possibility, there is also this option. So on the Destination Earth web portal, you can also see if you're an SME, for example, and want to create services for Destination Earth in the area of predictions, digital twins, Earth observations, and so on. There's also this option. It's visible on the Destiny platform. There's the onboarding method, which is presented there. So we also have this option, which in itself brings some computational capabilities with it.
Yes, clear. Thank you so much. I think this is a nice adding question. It's directed towards Michael, but I think all of you might have something to say on this. How do you see Destination Earth services differentiating themselves from existing Earth observation platforms?
Yeah, it's a good question. It's typically asked. So I think what can be said here, it's Destination Earth is, for example, unifying, bringing together the sort of modeling world. It brings together the sort of Earth observation. So the two pillars together. You've seen it as well in other platforms, but we have as well the connection of the HPC world to the OpenStack world. So there are a lot of things and elements that are brought together that are not available in other platforms. And we have as well, due to the architecture and the infrastructure with, for example, the data lake being close to the HPCs, we have the capability, for example, if a model is run on demand, etc., and the sheer amount of data that is produced, that can be then easily moved into the data lake to the close proximity, and then it can be immediately exploited and used by people. And that typically you don't have this combination in any other platforms existing. And also Destination Earth goes a bit across, because Daniel showed the picture about the different data spaces, and the aim is as well to be able then in the future to transfer and exchange data across other data spaces. And a lot of data spaces need climate projections and these scenarios for their modeling world. And so it effectively needs to be combined. And then if you see the link with the AI factories and the AI startup regarding the AI data labs that are now going to come, so it's all closing that together.
I would add here a bit the actual twin technology, meaning the prediction capability, which goes beyond the observation capability. So the underlying objective at a fundamental level of Destination Earth is to produce these two digital twins on weather and climate, which are predictions/simulations. So that would be the main purpose. And from this, we start to derive the what-if scenarios. My example of what will happen in a +2 degree warmer world. So all this variation can only be powered by the digital twin technology.
I can give one practical example, which was related to a question I saw in the chat as well. They were asking about how can Earth observation data help to look at traffic and what kind of resolution you could achieve. There is, for example, the European Ground Motion Service, which collects data from the Copernicus Sentinel-1 satellites, looking at individual points on the Earth and measuring the vertical and horizontal movement of those fixed points on the planet. And this is just the observation which is being presented publicly and freely for all. But as was said, you can't model that in this application. So you need would need to download those massive data sets with large amounts of time series in order to gain additional insights. And on Destination Earth, you have the compute to actually model and use the data. And therefore, I find it highly interesting, and it's very useful for evidence-based policymaking.
Thank you all for your insights. It was nice to have a little discussion almost. I have one final question, which I would also like to just open up to all of you. Is the integration of EU data spaces an ongoing effort? Is there a specific program or initiative for this? The participant who asked this is specifically curious to see how this integration will evolve.
Yes, there is. It's called simple. It's simple middleware. It's simple like the English word without the last letter, without the E. So just simple. Just search simple middleware. There's a lot of public information on it. And yes, this is an ongoing initiative which aims at integrating the data spaces together, both at a technical level and at a governance level. So including like the access rights in order to obtain access to the data.
Yeah, I can complement. The idea is that actually, as part of our work plan, we sort of aim to do a pilot for having the integration between EOSC and Destination Earth. And this pilot will go or start soon, over a period of 2 years. And they are simple. It's supposed to be used in that context to integrate in that pilot these two different activities and benchmark the way of working, and then opening maybe for the broader data space context. But I think, Daniel, maybe other pilots are ongoing as well in parallel to just between EOSC and Destiny.
Yeah, just for the context, EOSC is the European Open Science Cloud. It's another data space on its own, aimed towards scientific, so science research. So we are indeed aiming to pilot this integration to enable the exchange of data between the green data space, which is ours, and the EOSC.
Yeah, there's only one thing to add, I think, is that those integrations, if they are standards-based and those standards are openly described, then it's fairly easy to connect to those different data spaces. And how we come up with those standards is usually discussed in the specific work groups, which are embedded in broader structures like W3C and so on, CEMIC and whatnot.
Perfect. Thank you. I saw some links already being shared in the chat for the Simple platform. So great to see colleagues alike joining the session. Thank you so much, everyone. I would like to give a few minutes to Thore in case you would like to still present a little bit from the slides we missed, obviously, from your part of the session, and then we will wrap up. So if you have about 5 minutes if you would still like to cover your final insights.
So then I would just go to the last couple of examples because I think they complement the structure fairly well, which were
I think here the
those
examples.
two.
Yeah.
So just one example for observing data and one potential or Earth observation data, which is static in itself, not being able to use for modeling, like in Destination Earth. This is an example of a use case for forestry. There's often calamities happening, floodings or the bark beetle eating lots of trees. And if you look at a forest from a company point of view or from a nature conservative point of view for climate change, you want to know, okay, where did this happen and why? Has it to do with exposition? Has it to do with droughts? Has it to do with other conditions? And to do analysis. And this is easily doable using Earth observation data, for example, with the Copernicus data, where you can then look at how much of the forest was actually affected by a certain environmental condition and then generate pretty pictures, but the persons who are familiar with the data can then do proper analysis and try to make informed decisions about to reforest, plant new trees in essence on certain spots based upon the models that potentially run in Destination Earth or somewhere else, because trees take a lot of time to grow. And the last example I had was the ground motion service. So this is an example from the German ground movement or motion service, but there's also the European-wide initiative, and the data actually is the same. This is data derived from Sentinel-1 synthetic aperture radar, where one can measure certain points on the Earth with a signal and then calculate basically how the points on Earth are moving. And this is especially helpful for traffic, for example. If you look at infrastructure, you can see and monitor if certain regions like below actually sink, if entire neighborhoods are like lowering or rising or moving in other directions on the Earth. Or you can even look at bridges, for example, which is the picture above, and see the amplitude over this several years in order to figure out if, for example, the alloys used, the metal is stressed, or is it expanding or contracting based upon the environmental temperature, which then informs maintenance, which can be done predictively, for example. And if it's a bridge, which is, for example, a railroad, you could imagine that this affects traffic heavily. That would be
Great.
it.
Thank you so much for still sharing those examples. I think, yes, people are very appreciative that you still got some time to share those with us. I just have some closing remarks now. Some promotion for our next webinar. So at the end of February, we're going to have a webinar about open data maturity within Europe, where we'll have speakers sharing their progress across different countries and share key insights from the ODM reports. We saw a lot of keen people sharing their insights in the chat, and we definitely want to support people to keep discussion going. So please join us in the collaboration channel on the Data Europa portal, where you can have conversations about the topics discussed today and see any more further insights. And once again, we want to ask you for your opinions. So you can click above to access our survey to give some final feedback. We really appreciate any insights you can give to further improve our webinars. And then, yeah, we're wrapping up a bit early. So I want to again thank Thor, Daniel, and Michael very, very much for your insights on Earth observation data, and want to wish everyone a nice weekend ahead.